13.1, geometric sequences. Essential question, how can you define a geometric sequence algebraically? So what we're going to do today is we're going to write the rules for a geometric sequence. They're going to give you numbers, and we're going to write the rules. There's two different ways to write the rules. So just follow along as I read, and I'm going to point out on page 700 up at the top some important information that you need to put in your Cornell notes. Top of page 700. A sequence is a set of numbers related by a common rule. We're going to write two rules. One of them is called an explicit rule, and the other one is called a recursive rule. Now, you probably had these in Algebra 1, but you may not remember them. So I'm going to teach you again, and you might have had it even in geometry. All sequences start with an initial term. In a geometric sequence, the ratio of any term to a previous term is a constant. So it's going to go up by a constant number every time in the sequence. This constant ratio is called a common ratio and is denoted by R. In the explicit form of a sequence, each term is found by evaluating the function f of n equals ar to the n power, or f of n equals ar to the n minus 1, where a is the initial value. So I want you to write that in your notes. A equals initial value, which means the number we start with is the A. And R is the common ratio. Write that in your notes. R is the common ratio. That's the number we're multiplying by each time. The common ratio. Or some whole number. Note that there are two forms of the explicit rule because it is permissible to call the initial value of the term the first term, or to call AR the first term. So I'm going to give you two different formulas for explicit rule. Write these down. And then I'm going to explain what they mean when we get to the examples. It's explicit rule. The first one is f of n equals AR to the n power. F of n equals AR to the n power, where A stands for the initial value and R stands for the common ratio. The second one is f of n equals AR to the n minus 1. And I'm going to tell you which one to use when. Okay, it will be one of these two for explicit rule. And once you write the rule, that's all we're doing. We're writing a rule and not working anything out. Okay? Now let's read on to the next paragraph. A geometric sequence can also be defined recursively by f of n equals r times f times n minus 1, where either f of 0 is a or f of 1 is a. And again, depending on the way the terms of the sequence are numbered, f of n equals r times f n minus 1 is called a recursive rule for the sequence. So now I'm going to give you the recursive rule formula. And on your recursive rule, there's going to be stuff written at the end that I can't really explain now until we get to that problem. Okay, so recursive rule is, sorry, that's not right, R times, well, I should have put f of n there. Start all over. f of n equals r times f n minus 1. And after that, there will be some more stuff written, but I can't really tell you until we get to the problems. Okay? Those are your two formulas. Or actually 3. All right, let's go straight to example 1A, right there in the middle of page 700. It says, write the explicit and recursive rules for a geometric sequence given a table of values. Now, this is like problems 4 through 7 on your homework. The first thing we're going to write is the initial value. Initial value, which is the A. The A comes from the first number right there on the f of n row, on the y row. Initial value is 3. Then we're going to write the common ratio, which is the R value. You're going to get the R value by taking one of these and dividing by the one to the left of it. So what would 6 divided by 3 be? 2. Or you can pick any of them. You don't have to pick the 6 and the 3. You can say, what's 24 divided by 12? 2. Or 48 divided by 24? 2. And they all should be 2. Okay, so those are 2 of your answers. Initial value and common ratio. Explicit rule. You're going to write the explicit rule next. F of n equals A. What is A? 3 times R, 2 to the n power. Now, on your notes, I gave you either n or n minus 1. Which one do you use? If it is a 0 right here, then it's just going to be to the n power. If your table starts with a 1 right there, then you have to subtract 1. Because you want that to be a 0 here to start out with. Everybody understand? If it's a 0, it will just be an n. If that is a 1, then that would be an n minus 1. Okay? You can put that in your notes if you need to. Recursive rule. F of n equals R times F n minus 1. Now here's that extra stuff I told you had to write at the end. You're going to put n is greater than or equal to, it's either going to be probably a 1 or a 2 here. It's got to be the number just 1 greater than the starting number. So I'm starting here with 0, so this would have to be a 1. If I would start with a 1, then this would have to be a 2. And f of 0 equals 3. All of that makes up the recursive rule. Where did I get f of 0 equals 3? Where did that come from? Right there at the beginning. F of 0 equals 3. That was from this start. Okay, so you're going to have 4 answers. Initial value, common ratio, explicit rule, and recursive rule on 4 through 7. Any questions on that? Example B. Determine A and R, and then write the explicit and recursive rule. It's at the bottom of page 700. So my initial value which is my A, what would my initial value be? 1/25. What is my common ratio? Now, I said to take the second one and divide by the first, but those are fractions. So let's move on down here. What is 5 divided by 1? 5. What is 25 divided by 5? 5. So my common ratio is 5. Explicit rule. F of n equals, what's A? 1/25 times R, 5 to the n minus 1. Why minus 1? Because there's a 1 there. It didn't start with a 0. That's my explicit rule. Recursive rule. F of n equals R times F of n minus 1, where n is greater than or equal to 2, and F of 1 equals 1/25, and I got that from right there on the starting point. Any questions on that? Your turn, page 701. Write the explicit rule and the recursive rule for the geometric sequence. Okay, on the first one, what is A? What is the initial value? 1/27. What is the R, the common ratio? 3. Explicit rule. F of n equals A 1/27 times R to the n or n minus 1? N. I'm going to start the recursive rule over here because there's so much to write on it. Recursive rule. F of n equals R times F to the n minus 1. N has to be greater than or equal to 1. And what else? F of 0 equals 1/27. Number 5. What does A equal? 0.000 or 2 there?
Yes.
0.001? What does R equal? 10. My explicit rule would be what? F of n equals 0.001 times 10 to the n minus 1. Very good. What about the recursive rule? F of n equals 10 times f of n minus 1